Some boats are built to conquer oceans, others are built to carry thousands across the sea. And then, there are the ones that just make you ask, who thought this was a good idea? From floating fortresses to aquatic jet engines, these aren't ships that ruled the waves. They barely survived them. This is the story of the most absurd experimental boats ever built. They shouldn't have floated. But somehow, some of them did. A perfect circle is great in geometry, not so much in naval engineering. The Russian Navy discovered that the hard way in 1873 with one of the most bizarre warships ever floated, the Novgorod. At first glance, it looked more like a floating manhole cover than a battleship, but it wasn't a joke. It was a fully armed, armored war machine, at least on paper. Designed by Admiral Andrei Popov, the Novgorod was part of a radical experiment. Popov believed that traditional longships wasted too much space and couldn't carry enough armor or firepower without growing dangerously large and unwieldy. His solution? Ditch the hull entirely. Build a warship that was essentially a metal disc. That way, he reasoned, you could stack on thicker armor and bigger guns without increasing the ship's overall size. In theory, it kind of made sense. In practice, it was a floating disaster. The Novgorod was impossible to steer accurately. It didn't cut through the water. It just sort of wallowed in it. When the ship's massive guns fired, the recoil would cause the entire vessel to spin on its axis like a top. Targeting was a nightmare. It couldn't aim, it couldn't chase, and it certainly couldn't escape. In rough seas, it pitched and rolled uncontrollably. Sailors reportedly got seasick while docked. It was so slow that enemy ships could outmaneuver it with ease, assuming they even bothered to attack, which they rarely did, since the Novgorod couldn't really hit anything anyway. Despite these obvious problems, Russia doubled down and built a second one, the Vice Admiral Popov. Unsurprisingly, it performed just as badly. Both ships were quietly retired after only a few years of service, having never seen real combat. During World War II, British engineers proposed something cold, literally. In the face of German U-boats wreaking havoc across the Atlantic, conventional solutions weren't cutting it. So Lord Mountbatten and inventor Geoffrey Pike pitched a radical idea to Winston Churchill. What if the Allies built an aircraft carrier out of ice? But not just ordinary frozen water. Enter Pykrete. A strange but ingenious mixture of ice and wood pulp, or sawdust. When frozen together, it created a material that was far stronger than ice alone, highly buoyant, resistant to bullets, and incredibly slow to melt. It could even be cut and shaped like wood. The proposal, dubbed Project Habakkuk, was nothing short of colossal. The ship would be over 600 meters long, longer than 3 football fields, and 60 meters wide. It would displace 2 million tons and be practically unsinkable. Torpedoes. Harmless. The vessel would just absorb the blast and refreeze itself. It was, in theory, the ultimate mobile fortress, a floating airfield capable of supporting transatlantic operations. And believe it or not, they actually tried it. A small prototype was secretly constructed on Lake Patricia in Alberta, Canada. It worked. Sort of. The prototype floated just fine. But almost immediately, the engineers ran into a serious problem. It was melting. Even in the cold Canadian climate, the Pykrete structure began to deform. To keep the massive hull intact, the full-scale version would have required an enormous refrigeration system, one that had to run constantly, even in the North Atlantic. The sheer amount of steel, coolant, and manpower needed to keep the ship from turning back into slush made the project absurdly expensive and logistically impossible. By the time they figured all that out, the war had moved on. Aircraft range had improved, the U-boat threat was declining, and the urgency was gone. The project was scrapped. In the 1980s, during the height of the Cold War, the US Navy set out to explore a bold idea. Could a warship be invisible? Not literally, of course, but invisible to radar. With advances in detection systems and guided missiles, stealth technology was becoming a top priority. The Air Force had the F-117 Nighthawk, the world's first operational stealth aircraft. Now the Navy wanted its own Ghost, a ship that could sail undetected through hostile waters. Enter the Sea Shadow, a vessel so secret it was built inside a floating barge at night to avoid satellite detection. Developed by Lockheed Martin's Skunk Works in collaboration with DARPA, it looked like something straight out of a science fiction movie. Angular, matte black, riding on twin submerged hulls in a catamaran-like design. Its shape scattered radar waves, its low profile avoided visual detection, and its materials absorbed signals. On paper, it was revolutionary. In reality, not so much. The Sea Shadow was packed with innovation and limitations. At only 50 meters long and 15 meters wide, it was far too small for any practical combat use. It had no weapons, no real cargo space, and no mission-ready equipment. It wasn't built for battle. It was a floating laboratory. It couldn't handle rough seas, which severely limited its operational range. Its stability came from a small waterplane area twin hull, swath, design, great for calm waters, not so much for open ocean. And while it was stealthy, it was also expensive, strange-looking, and difficult to integrate into standard Navy operations. Why sail when you can walk? That, apparently, was the thinking behind one of the strangest vessels ever to set foot, or rather, legs, on the water, the Proteus. Unveiled in the mid-2000s by Marine Advanced Research, the Proteus looked less like a boat and more like something that had wandered off the set of a science fiction film. Imagine a giant, robotic spider skating across the ocean, with long, spindly legs mounted on inflatable pontoons, gliding over the waves like a mechanical water strider. Its design was based on something called a Wave Adaptive Modular Vessel, or WAMV. Instead of slicing through waves like a traditional hull, the WAMV was intended to ride above them, with articulated joints and flexible connections that allowed each leg to move independently. The idea was to create a vessel that could adapt to ocean conditions in real time, offering stability, fuel efficiency, and access to difficult marine environments. And it sort of worked. The Proteus could float. It could even move. Slowly. But the reality didn't match the hype. The vessel was notoriously noisy. The mechanical legs and joints clattered loudly with each motion, making it impractical for scientific research or stealth operations. It was fragile, too. The flexible design that allowed it to move with the waves also made it highly vulnerable to heavy seas. In rough conditions, the structure twisted and buckled, limiting it to calm, protected waters. It had almost no payload capacity, no real onboard facilities, and no way to defend itself or perform meaningful missions. It looked cool, yes, but it was more of a concept car than a real vehicle. Eventually, the Proteus was retired. Today, it's a museum piece, a technological curiosity preserved more for its weirdness than its usefulness. In the early 1900s, Norway sought to defend its waters with a new kind of warship. Compact, heavily armored, and capable of delivering powerful blows while remaining difficult to target. The result was one of the strangest naval experiments in Scandinavian history, a low-profile coastal defense ship that looked like a floating bunker. On paper, it was brilliant. The vessel was designed with a minimal silhouette to make it harder to hit. It had thick armor plating, a shallow draft to navigate tight inlets, and a massive forward-facing gun intended to deter any intruding fleet. The idea was to create a nearly impenetrable war machine, a stationary sea fortress that could protect Norway's vulnerable shoreline without the need for a full-sized navy. But paper is one thing, physics is another. As soon as the ship was tested, its flaws became painfully obvious. The main issue? Balance. The massive gun mounted on the forward deck was so heavy and so powerful that the entire ship would shift violently when it fired. The recoil wasn't just a jolt, it was a seismic event. Sailors reportedly had to brace themselves against the bulkheads to avoid being thrown off balance. In some cases, unsecured items below deck would slide or tip over. It was so top-heavy that firing a single shot could send it dangerously listing to one side. Stability in open water was practically non-existent. Any attempt to use the main gun in rough seas would have risked capsizing the entire ship. Unsurprisingly, the vessel never saw combat. In fact, it barely saw open water. It was stationed along the coast, occasionally moved between harbors, but largely avoided any serious deployment. Its firepower was formidable, yes, but only in theory. In practice, using it came with serious risk to itself. It was eventually mothballed, then scrapped. Few photographs of the ship remain, and fewer people remember its name. But naval historians still whisper about it as one of the more spectacular design failures of the pre-World War era. In the 1990s, Japan set out to build a ship that looked less like a product of naval engineering and more like something that belonged on the deck of the USS Enterprise. The vessel in question was the Yamato One, a sleek experimental craft that ditched traditional propulsion methods altogether. No propellers, no jets, no screws. Instead, it relied on something out of science fiction: magnetohydrodynamic propulsion, or MHD for short. A technology that, at least in theory, could revolutionize how ships move through water. So how does it work? In simple terms, MHD propulsion pushes seawater using magnetic fields and electric currents. Since seawater conducts electricity thanks to its salt content, the ship could theoretically create a powerful Lorentz force, using magnets and electrodes to accelerate water out the back of the hull. No moving parts, no mechanical noise, just a near-silent, steady push forward. When the Yamato One was unveiled, it immediately captured global attention. It was sleek, futuristic, and promised a new era of silent, vibration-free naval travel, perfect for submarines, research vessels, and maybe even stealth warships. But there was a catch. Actually, several. For starters, the ship could barely move. Its top speed was a disappointing 15 kilometers per hour, slower than a decent bicycle. That wouldn't have been a deal breaker if it hadn't required an enormous amount of power to do even that. The onboard superconducting magnets and cryogenic systems consumed tremendous energy, and the efficiency was abysmal. In essence, it was like powering a scooter with a nuclear reactor. It made one short voyage in 1992 across Osaka Bay, mostly as a demonstration, and that was the extent of its career. No military contracts, no commercial adoption, just a brief moment of glory for one of the most ambitious and awkward marine experiments of the 20th century. Today, the Yamato One remains docked at a pier in Kobe, Japan. Still intact, still futuristic, still not going anywhere. Technically flying, but legally classified as ships, the Soviet Akranoplans were some of the most bizarre and imposing vehicles ever conceived. These were not airplanes, not boats, not hovercraft. They were something else entirely. Massive winged leviathans that glided just a few meters above the surface of water, exploiting a phenomenon known as ground effect. Born in the depths of the Cold War and built in secrecy by the Soviet Union, the Lun looked like a battleship that had grown wings. It was nearly 75 meters long, with 8 massive jet engines mounted atop its forward fuselage, armed with 6 anti-ship missile launchers. It was meant to fly just above the waves of the Caspian Sea at speeds of over 500 kilometers per hour, skimming the surface too low for radar to detect, yet too fast for traditional naval defenses to intercept. In theory, it was the perfect military surprise weapon, part plane, part warship, and impossible to categorize. But the reality was far less impressive. The Lun could only operate in calm seas, and only over water. It needed long stretches of flat surface to get airborne and even longer ones to land. Crosswinds, waves, and even slight weather disturbances posed serious threats. Maneuverability was limited. Turning required massive open space, and sudden evasive action was simply not an option. Unlike aircraft, it couldn't fly over land. Unlike ships, it couldn't survive rough seas. And unlike either, it had no meaningful flexibility. It was locked into a narrow operational envelope, fast but fragile, powerful but profoundly limited. Only one Loon-class Ekranoplan was ever built. A second one was started but never completed. With the collapse of the Soviet Union, interest and funding evaporated. The lone finished model never saw combat, never fired a missile, never fulfilled its potential. Today, it rests on a beach near Derbent, in southern Russia, slowly rusting under the sun. Part aircraft, part seaborne curiosity, now stripped of engines and dignity. Some ships conquer oceans. These barely made it out of harbor. They were born from ambition, not caution. From the burning desire to innovate, to defy convention, to build something no one else dared to imagine. Engineers and admirals dreamed of unsinkable fortresses, flying boats, stealthy predators, and futuristic machines that would change naval warfare forever. But dreams are one thing. Physics is another. These vessels never saw the battles they were built for. Some couldn't steer, some couldn't shoot, others couldn't even stay upright. They sank under their own weight, shook apart from recoil, or floated just long enough to prove they never should have been launched in the first place. They became cautionary tales, expensive experiments, glorious failures, because not every idea should be built, not everything should float, and sometimes the most important test a ship can fail is floating at all.